In this video, I'm going to talk about how to determine whether an acid and a base are strong or weak. So let's first talk about what that actually means. To be strong, doesn't matter whether it's an acid or a base. What that means is that when you mix it with water, it completely dissociates. That means it completely comes apart into ions. So if you take a base like NaOH, which is a strong base, and you dissolve it in water, it comes apart into Na plus ions and OH minus ions. Notice the O and the H stay together, hydroxide, and the Na splits off. And 100% of that NaOH will come apart into its ions. So that is a strong base. The only strong bases are ones that have this OH at the back, hydroxides. So any other bases that you see, like NH3, that is not strong. That is a weak base. The only strong ones have an OH at the back. At the front of a strong base, you have a metal, and that metal has to come from, hydrogen's not a metal, has to come from these two orange columns here, column 1 or column 2. If it comes from column 1, it will look like LiOH, NaOH, KOH. Notice there's only one OH group on your metals from the first column. All of them do it like that, and they are all strong. In the second column, we would have Be, and then because it has a +2 charge, it takes 2 OHs to balance it out. Mg, again, second column, we need 2 OHs to balance it out. And all the way down that column. Those are also all strong. Those are the only strong bases. If you see anything else besides these 2 columns in the front, it is weak. So for example, if you saw copper in the front, that is weak, which means it doesn't come apart 100%. Only a little bit of it comes apart and the rest of it stays together. So that would be a weak base. So the only strong bases are the ones that have a metal from the column 1 or column 2 on the periodic table in front, and then either 1 or 2 OHs at the back. Those are the only strong ones. All others are weak. Now let's look at acids. Looking at acids, it's the same idea. If it's a strong acid, it's going to completely come apart when you put it into water. Acids have a hydrogen generally written in the front. For example, hydrochloric acid is HCl. This is a strong acid. So when you put it into water, it comes apart into hydrogen ions and chloride ions, and basically 100% of it comes apart. And that's what makes it a strong acid. When determining whether an acid is strong or weak, first we have to see what kind of acid it is. So we have 2 types. The first type are called binary acids. Binary, bi means 2. There are only 2 elements in a binary acid, and one of them is going to be hydrogen. Examples would be HF, HCl, HI, HBr, H2S, H3P. Notice there's only 2 elements. There may be more than 2 atoms, but there's just hydrogen and another element. The only strong binary acids are HCl, HBr, and HI. These 3. All others are weak. And HCl, Cl is here, Br is here, I is here. So it's these middle 3 halogens with a hydrogen in the front. Those are the only strong binary acids. So anything else is going to be weak, weak, weak. Our second kind of acid is a ternary acid. And these have 3 elements. One of them is going to be a hydrogen. Then you have a middle element, and then you have oxygens on the other end. So the basic formula is going to be some number of hydrogens, some other element, some number of oxygens. Those are going to be your 3 elements. To determine if it's strong or weak, we have to do some very simple math. So let's look at some different acids. Let's say we have HNO2, HNO3, H2SO4, H3PO4. That should be enough to show us what we need to do. So notice they all have a hydrogen in the front, they all have oxygens at the back, and the middle element is going to be one of these nitrogen, phosphorus, sulfur, one of these middle guys right here. It could be carbon, we could have a H2CO3 as an acid. The way that you do this is you take the number of oxygens minus the number of hydrogens and figure out what that is. If that number is 2 or larger, it is a strong acid. If that number is 0 or 1, then it is a weak acid. So let's look at our examples. This one, we have 2 oxygens minus 1 hydrogen equals 1. Weak. This one, we have 3 oxygens minus 1 hydrogen equals 2. 2 is strong. Next one, we have 4 oxygens minus 2 hydrogens equals 2. That is strong. The next one, we have 4 oxygens minus 3 hydrogens, which equals 1. That is weak. And our last one, 3 oxygens minus 2 hydrogens equals 1, which is weak. There's one more kind of acid that you may see, and that's an organic acid, and they are always weak. So the only thing you need to worry about is figuring out which ones are strong, and then everybody else is weak. That's all there is to it. I hope this has helped. Have a great day and come back and visit me for other videos.